Good morning, class. Today, 1.4 is on polygons. Again, it's a day that's filled with lots of definitions, but should be pretty short and sweet. A polygon is a closed figure in a plane. It's formed by connecting line segments from endpoint to endpoint. Each line segment is called the side, and each endpoint where the sides meet are called a vertex. So we have some examples of polygons here, and these are vertex or vertices for these figures. So every line that's between those are going to be a side. Now in the not a polygons, we see because of the curve and if they cross or it's open and they cross, those are examples of why they're not a polygon. A polygon has got to be a closed figure. All right, so we classify polygons by the number of sides it has. So anything past 12 sides, we call an n-gon, and n's the number of sides it has. So we could have a 25 gon, and that means it has 25 sides. Or we could have 144 gon, it has 144 sides. Anything less than that, we have names here. So three-sided figure is a triangle, four-sided is quadrilateral, and we have lots of quadrilaterals. Rectangles, squares, kites, rhombus, trapezoids, variety of them. 5 is pentagon, 6 is hexagon, 7 is heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 11 undecagon, and 12 is a dodecagon. All right, so when we name polygons, we list the vertices in consecutive orders. So here we have pentagon, A, B, C, D, E. You don't have to start at A. You could call it pentagon. We could start at D, C, B, A, E. As long as they are in order. We would not want to call it pentagon. C, E, A, B, D, because see that those are not in order, so we don't want it to be like that. So usually triangles, same thing. They put the little triangle symbol out in front of it instead of naming it with the pentagon. Then we have diagonals. Diagonal is a line segment that connects to non-consecutive vertices. Non-consecutive just means that they're not right next to each other. So in the previous slide here, we talked about consecutive order, so that they needed to go in order. So the A, B, C, D, etc. Here we're talking about non-consecutive vertices. So that's not connecting. Like E to F, that's not a diagonal, that's a side. But F to D is a diagonal. E to C is a diagonal. Okay, if the polygon is convex, convex examples are right here. All the diagonals occur inside of our polygon. If it's concave, meaning it goes in somewhere, such as here's concave examples, then you see that the diagonals go outside of the figure. Not all of them will, but some of them will. All right, congruent polygons. There are two polygons that are congruent if they are exactly the same in size and shape. So angles and side measures need to be exactly the same. So if we look at this example here, all of our angles have been marked as congruent and all of our sides have been marked as congruent. And the thing with congruent polygons, when we talk about congruent polygons, the angle or the vertice that matches has to match in the same order when we list them. So CAMP is congruent to SITE, but we wouldn't put C and match it with I because those are not congruent. So you want to make sure that each of the letters are matching up with the exact same letter that has the same measure from the next polygon. All right, equilateral, we've heard of equilateral before, probably in a triangle. All sides are equal in length, so we have equilateral picture here. So all the sides are the same. That doesn't mean that all the angles are the same. Then we have equal angular. That says all the angles are the same, but it does not imply that all the sides are the same. So you'll see here we've got two sides that are a little bit longer than the rest. And a regular polygon is when they're both equal angular and equilateral. So all the sides are the same in measure and all the angles are congruent too. So sides are congruent and angles are congruent. Then that becomes what's called a regular polygon. All right, so like I said, lots of vocab, but not too long for a video. If you have any questions on this, we can talk about them on Monday. We'll see you then.